activities,
Yeah.
one will write actually, correct,
Yes, sir.
rest
Yeah.
will, copy down the same thing.
Yeah, yes, sir.
I want to avoid that. That's it, basically.
Like, to be frank, we'll split the questions, sir, actually.
Mm-hmm.
We used to, after writing everything, we'll be collaborate all the things and we do.
No, that's good actually, but what is the contribution from everyone is very important, correct? No?
Yes, yes, sir.
Because only four of you sit together and write, and rest they're not come for the discussion and simply they take it up and write it, submit. It may not be good, no.
Yes, sir.
That's the intention, so that at least they start writing it by their own. And also those who have done some collaborative, you should tell them, we won't give you, right, like that. Hmm?
So friendships are, we can't.
So like that, huh?
Yeah.
But then
But
what is the learning is going to happen ultimately?
yes, sir. That's actually wrong, sir. As come to the learning part, but this, yeah,
Because once you put some effort and some understanding and some learning, then they're going to acquire some knowledge, right?
yes, sir. That's
Then
right.
they will get good employment opportunities accordingly.
Yeah, yes,
If they're not doing, they won't get, right? No.
yes, sir.
Yeah, that's the whole idea is. Have you designed any paper? Literature review paper, I told you, no?
No, sir.
Do it while
Uh,
you're doing. Hmm?
o- okay, sir. Okay, sir, I will do.
Because see, you are there at home, right? And you're attending your internship. If you're not putting or placing yourself with many activities, how are
Yeah.
you going to pass your time? Hmm?
Yes, I'm reading research papers for the schooling optimization and all, sir.
Hmm.
So it's also I will be taking help of that and I'll try to do this.
Hmm. 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 Okay. Yeah, fine. Do you have any clarifications in any, chapters so far we have discussed, right, from 1 to 3 at any point of time?
No, no, sir.
Yes. Have you gone through the slides which I have shared from 1 to 3 thoroughly?
Not thoroughly, sir. Before first quiz, one day before first internal, I go. I was slightly read about all the topics and not deep, sir.
Hmm. Hmm. Have you referred any Cisco material which I have forwarded?
Yes, sir. Like while preparing the PPT, I just went to that Cisco materials,
Hmm. Hmm.
but I just read. I didn't take any topics from that. Means like I just read slightly, but I didn't take any. But I referred papers only, sir. But I just while reading, uh, I just think of like, can I use for this? My topic was congestion control. For that, I read.
Okay. I think I have shared there will be in three materials right now so far.
Yeah, yeah,
Yeah, fine. Yeah, so now I'm in fourth chapter. That's in
yeah.
unit 4,
Yes, sir.
where I completed effects of congestion in the last class. Right.
Yes, sir. Yes, sir.
So I'll just share that screen right now. You can start explaining by yourself. What you could understood from it. Okay, because you might have
Okay.
studied. Huh?
Yeah, yes, sir.
I'll share
Okay.
that. Let us understand your views on congestion control. I'll
Yeah.
share my PPTs. By going through it,
Okay.
you can share it. Okay.
Okay, sir.
I'll share it right now. Hmm?
Okay.
One minute. It's visible now.
Yes, sir. Not that.
Visible now.
Yeah, yes, sir. Yes, sir.
I think I was talking about water congestion. Okay.
Yes, sir.
Network congestion in the last class. What is internet congestion? Okay.
Yeah, yes, sir.
Yeah. I think I have stopped at this stage. Could you explain this? What you can understand from this particular slide?
Mm. Yes, sir. When network is working, sender, router, and output will be there. So when the packets are started moving from the sender, so at the output, when sender will be start fast, when send the packet very fastly, so routers can be have some capacity to accept the some limited some continuously limited up packets. But when it is sending too much, so routers couldn't be accept all the packets. So if the packets are too fast to the routed, so there'll be some there is chances of discarding of the packets also there, sir. This is what in the third point I understood. So there will be that's why there is some chances of losing of the packets, that's a discarding of the packets, so losses will be there. So whatever the packets accepted by the router, that is will be when router also there, like sender receiver has some capacity, it has to send as per that capacity. It should not be like more than that capacity of the receiver. Though there are also some chances of not some chances, almost there will be chances of losing of the packets only. Stored input buffer routing. This, yes, sir. This is what I understood.
Yeah, that's fine. Actually, in order to say the effects of
Yeah.
congestion, right,
Yes, sir.
uh,
Yeah.
we need to look for three components basically. Okay.
Yeah. Yes,
One
sir.
is an input buffer.
Yeah.
The another one is an output buffer.
Yes, sir.
1 minute.
Okay.
ಒಂದೇ ಸೆಕೆಂಡ್ ಸೈನ್ ಆಗ್ಬಿಟ್ಟು ಟ್ರೈ ಮಾಡ್ತೀನಿ ರಾಜಶ್ರೀ ಇಲ್ವಾ ಹುಡುಗೊಂದು ಕೋರ್ಸ್ ವರ್ಕ್
ಇಲ್ಲ
ಇಲ್ಲಿ ಮೇಲ್
ಕೋರ್ಸ್ ವರ್ಕ್. ಇದೆ
ಇದೆ ಚಲನ್ ಕಟ್ಬೇಕು
ಬಾಗಿಲು. ಹಲೋ ಹಲೋ.
Hello, sir.
Yeah. 1 minute.
Oh,
Yeah, I was talking about three important
input
components
buffer.
which you need to remember. Okay,
Yes, sir.
one is an input buffer, output buffer, and in between there is an packet queue. Correct?
Yes, sir.
Because when we talk about there is an input buffer, the data may come to input buffer from so many right now network sources basically. Okay,
Yes, sir.
which are going to be queued up in a network traffic,
Yes, sir.
right?
Yes, sir.
Unless until if you are not handling serving each and every packet in the same order which you get it,
Yeah.
definitely there is a congestion at your network, right?
Yes, sir. Yeah.
What you need to do, you need to discard some of the packets maybe to avoid there be the congestion. That's one thing. Or else you have to do some kind of there'll be flow control, right? Do you understood what is flow control is actually, where it happens basically?
Uh, Flow control. It's like it's like a transmission data rates are like
Yeah, yeah, correct. See,
yeah,
it happens at the source end most of the time.
yeah. Okay.
Whatever the traffic you send, right?
Yeah.
You need to control at the source itself all the time. Hmm?
Okay. Yes, sir.
If you just send it just like that without
Yeah.
controlling it at the source, it
Yes, sir.
leads to there will be congestion again.
Yeah. Yes, sir.
Correct.
Yeah. Yeah.
That is what has happened in case of there will be traffic signal in Bangalore most of the time. Correct,
Yes, sir.
unless if they are not controlling it, if the traffic comes and if they say go for everyone, there is a congestion occurs. But if they control it, right, with some kind of mechanism, certainly what happens, there won't be any congestion, right?
Yes, sir.
The operation is going to happen very smoothly. Even this diagram looks like there'll be a traffic circle itself. Hmm? Where from the four roads, the vehicles are coming in to a particular junction and passing on. That's it. Hmm?
Yeah.
Right? Yeah, you can talk about, go through this and you can explain this particular slide.
Yes, sir. Like, so as we said, like buffers will be store the data from the input devices. So, from the sending the packets direct, it's not directly from the input. It will be passing from the buffers. So after that, it will be sending to the router. Router has to make the decision. So packets move to the output buffer, not directly to the output buffer. Output. So output buffer means like that will be some data will be stored in the buffer before going to the directly to the output. So so make it like if I made it very slow of the data transmission, so there will be a RTT time will be there, so timeout will be finished. So make it some certain, it's not as fast as not as at not more fast, because if I pass more fast there will be chances of losing the packets and congestion will be occurs. So make it some exact flow. So if the packets arrived at fast the router or to be, so buffers will be fill so it'll be like buffers will be overflow at that time if it is more fast. So definitely so packets will be discard and can can use the overflow control. So can we use the overflow control at the source side and the destination side both, or like only at the source side, sir? Sometimes like
Only,
from
yeah.
yes, sir. Like from source input buffer to router, they are sending some packets. Like so from if I mm, from if it is from router to receiver side, like is there need of flow control at receiver side also?
No, no, no. See,
Okay.
there
Yeah.
won't be any question of right flow control at the receiver side.
Okay.
Okay. I mean,
Yeah.
see, flow control in the sense, let us say when you have a networks of networks, right?
Yes.
When
Yes, sir.
you have, there is an S1, S2, S3, S4, S5, right
Yeah.
now.
Yeah.
Then if, your S3 is going to become a source, you need to think about it like that it is. You understand?
Okay. Yes.
When
Yeah.
I'm
Yeah.
taking S12, there will be an S10. S10 is going to become my destination point, right?
Yeah.
You
Yes, sir.
cannot control your data at S10. You need to control
Yeah.
at S1.
Yes, sir. Yeah. Sure. Sure.
But
Definitely.
however, when it is passing on via there is an intermediate, networks, right?
Yeah. Yes, sir.
You can have some control at S2, some control at S3, some control at S4 like that. That's that.
Yeah. Okay.
You understand?
Yes, sir. And then in the sense like in the router side also, like in, is there need of some flow control?
Yeah, that's what I mean. See,
Yeah.
because what
Yeah.
happens, even
Yeah.
though initially, if I say
Yes, sir.
it is something like that. Let us say you are traveling from from your place to Bangalore. Okay,
Yeah. Yes, sir.
your source is your native, correct? But
Yes,
as
sir.
and when you start from your place, when you come to the other place,
Yeah.
there may be a traffic, correct?
Yes, sir.
There won't be traffic from your place to the next station, or maybe to
Yeah.
the next station. But some point of time, there may be a traffic somewhere else, right?
Yes.
The flow control need to happen at that particular point again.
Yeah.
So when that is going to become the source actually, right?
Yeah. Yes, sir.
Because you cannot consider your place is going to become a source when you reach S1 to S2, S2 to S3 like that.
Yeah.
It keeps moving.
Yes, sir.
Okay, it's going to become like that. Hmm?
Yeah.
And also, right, they've used one more terminology that is an statistical time division multiplexing. Correct?
Yes, sir.
What your understandings on statistical time division multiplexing?
Statistical.
I think you need to remember here, you know,
Yes, sir.
uh, multiplexer and demultiplexer concept actually. Hmm?
Yes, sir.
Okay, what happens? Uh, the data may be coming into your network from a different sources. Okay,
Yeah.
there you do there is a multiplexing, right?
Yes, sir.
Then for each data stream or input stream, okay,
Yeah.
time slots are going to be allocated dynamically according to the demand. You understood?
Yes, sir.
This may happen in a round robin fashion, basically.
Yes, sir.
If you don't have any data stream for that packet, obviously it skips that to the next stream and forwards it. That's it. Yes.
So like then why it's a static, so
Huh?
statistical? Why it's a statistical? So like it will be dynamic. Like there is no fix of packet allocation will be there. Like it's a
Yeah.
flow.
Yeah.
Then it would have been a dynamic flow.
No.
So why
See,
they call
time
it?
slots are going to be allocated dynamically,
Yeah.
but that is in a statistical concept basically. Let us say you have 1 2 3 4, for example.
Yeah.
One, yeah, first round is 1 2 3 4, second round is also 1 2 3 4, third round is also 1 2 3 4. It is going to become like that.
Okay. Yes,
In
sir.
case if it is not required for the first one, obviously it will allocate for 2 3 4.
Okay.
Even if it is not required for 1 2, it will allocate to 3 4. Because even in case of writing a Gantt chart for round robin scheduling, that's what you will do now. Let us say process
Yes.
required some 10 unit of time slots. Okay. Hello.
Yeah. Yes, sir. Yeah.
Yeah, process P1 requires 10 units of time slot. P2 required some 8 units of time slot. P3 required 6 units of time slots. P4
Yeah.
requires maybe 4 units of time slots. Correct.
Yes, sir.
Then the quantum time is going to become say 4, right? During the first instance of a time, what will happen? It will allocate P1, P2, P3, P4. Correct.
Yes, sir.
Yeah, during the next iteration, what happens? Again, it will allocate P1, P2, P3, provided if it is required, if it is within that limit, correct,
Yeah. Yes, sir.
P4 is doesn't require anything. Obviously, again, it will come back to P1.
Yeah.
That's where we are trying to say it is an dynamic.
Yes, sir.
And why we say statistical is it repeats that in the same fashion, basically, provided if it is required.
Okay. Yeah.
You understand?
Yes, sir. Yeah.
That is why we say that like that. Hmm?
Yes, sir.
I think whatever the previous slide details are there. That complete
Yeah.
explanation is available here.
Yes. Yes, sir.
I think you understood what is input buffer, what is output buffer, what is
Yes, sir.
multiplexing, what
Yeah.
is statistical time division multiplexing is. Any
Yes.
doubts on input buffer and output buffer?
No, sir. No doubts.
No doubts. What is according to you is a buffer is?
Buffer is data storage, one.
Hmm.
Yeah.
It's a memory basically, temporary
Yes,
memory
sir.
you can
Yeah.
just say. Correct,
Yes, sir. Yeah. Yes, sir.
Right. Always we have there will be a finite size of storage space for
Yeah.
every task whatever we do. That's why we say that what is the buffer size you have it before doing something. Okay, unless you don't
Yes,
have there
sir.
will be the buffer size, you never move that file to into it. Correct,
Yes. Yeah.
even
Yes,
if you
sir.
take your pen drive itself or your hard disk itself, you check whether it is possible to move my file into that storage or not. If not, you're trying to use some higher capacity of storage. Hmm?
Yeah. Yes, sir.
Right, no, that's where also there's a congestion. Correct, you are trying to push some data of higher the size into the lower storage of device. It may not be possible. It leads to there will be right some loss of data into it, right?
Yeah. Yes, sir.
Okay, that's what is happening. Yeah. See here, effects of congestions are, outdated or non-compatible hardware, too many devices, bandwidth hogs, poor network design, and subnets. Can you describe each word? What your understanding for each word?
Yes, sir. So, outdated, non-compatible hardware is like is one hardware is there. If I run some softwares, it's not capable to run that software. So, like it's not comfortable for this. Like example. if some OSs will be there, some computers. So if I run some in Windows 10, if I run some other software which is not compatible with that, so in such cases it's not capable to run that software. It's like that. So like as I said, like some hard disk and pen drive is there. Uh, if I add the more data, if I have 8 GB pen drive, if I want to add 9 GB of data, it's not comfortable with that. Like this, I just for my perspective, um, too many devices means sometimes like when network is flowing, if there are using of so many devices, like there is chances of more congestion will be there. Instead of, if 2 3 devices are there, it can easily flow through that network, like easily can networks can packets can flow. So bandwidth hogs means like if there is like some every network have been running under some certain bandwidth only. Like if it is more more traffic will be happens in the network, more than the bandwidth. So that's what. So poor network design and subnets, like if it is poor network, then obviously uh, network, it will not be good, so
Mm-hmm. Yeah, that's correct actually.
yeah.
See, let me talk about outdated or non-compatible hardware. Correct.
Yes, sir. Yeah.
Let us say presently,
Yeah.
okay, what is the technology we are using, right, for the communication purpose? Is it a 1G, 2G, 3G, 4G, or a 5G?
Yeah.
What we're
Hello.
using? It's we are using currently, that's an 4G, right?
4G. Yes, sir. 4G.
Because all your smartphones are going to work on they'll be in 4G devices
Yes, sir.
comfortably. Okay.
Yeah.
Let us assume that you have a device with you, maybe 2G
Yes, sir.
or maybe 1G.
Yeah.
If I want to receive the data and I want to communicate with you, will it be possible?
No, sir, it's not possible.
Not possible. That's an outdated, correct?
Yeah. Yes, sir.
Or non-compatible hardware for the present technology what we are using it.
Yes, sir.
Correct?
Yeah. Yes, sir.
Let us say, even let me talk about in terms of there will be your systems, for example,
Yes, sir.
right? You have a system of, Pentium machine with you,
Yes.
where I want to, install, right, the present software into
Yeah.
that system. Will it cope
Yes.
up with that?
No, sir.
It is not possible. It is an outdated
Yeah. Yes, sir.
because
Yeah.
the boards which they have designed,
Yeah.
okay, never support such kind of software or APIs. Basically,
Yeah. Yeah.
it's outdated or a non-compatible hardware.
Yes, sir.
Let me relate that into a computer network technology now, right?
Okay. Yes, sir.
Let us say you have studied, Ethernet technology, right?
Yes, sir. Yes,
With
sir.
a different, capabilities like, right, 10
Yes, sir.
Mbps speed, 100 Mbps speed, 1000 Mbps speed, right, 1 Gbps speed, right, 10 Gbps speed, or 40 Gbps speed, something like that.
Yes.
Correct?
Yes, sir. Yeah.
Suppose if I have the present, you know, right, designed switches and the routers,
Yeah.
if I install to my 10 MB speed of network, will it be possible?
No, sir.
No, that is an outdated. Correct.
Outdated.
It's
Oh,
a
yeah, yeah.
non-compatible hardware.
Yeah.
Even if you are trying to use it, it may be possible sometimes, but what will happen? It leads to a congestion.
Yes, sir. Yeah.
You understand? You know,
Yes, sir. Yeah.
that's how we should talk about it basically,
Okay. Yeah.
right?
Yes,
One
sir.
minute, some disturbance is there. I'll just close that
Okay.
door.
Okay. Okay, sir.
Yeah, second one is too many devices. Correct? Hello.
Yes, sir. Yeah.
Yeah. Uh, right. Mention some points on too many devices.
Yeah. Yes.
What happens when you use too many devices? Very simple thing.
Mm, it will be late, sir. Late flow. Mm,
Let flow.
yeah.
Yeah. Accessibility. Correct.
Yes, sir.
Because when you're trying to connect too many devices to your network resources, okay,
Yeah.
your resources are going to be shared among all.
Yes, sir.
Due to that, what will happen? The resource which you may require to do some operation may not be available during a particular instance of a time, right?
Yeah.
Then it leads to congestion again.
Yes, sir.
Correct,
Yes, sir.
it is something like that. You studied what do you call in case of process synchronization with respect to dining philosopher's problem.
Okay.
Yeah, correct. Five professors are sitting right around the table where resources are available in a bowl, right now.
Yes, sir.
Only right, two chopsticks are available, and everybody would like to, eat right the food, whatever it is there in the bowl. Correct.
Yes, sir.
How they are going to, handle that particular situation, right? Here,
Yes, sir.
here we talk about a process synchronization, correct?
Yes, sir.
But if you do that synchronization here, what will happen? It will happen to the congestion, obviously,
Yes, sir.
correct?
Yeah.
You cannot have there will be too many devices because everybody trying to push some data into a traffic. It is something like that. Too many vehicles on the same road leads to congestion. Simple,
Hello.
right?
Yes, sir.
Yeah, hello. If you
Yes, sir.
deviate your traffic in a
Hi. Yes, sir.
different
Yeah.
path, right,
Yes, sir.
there won't be any congestion basically. Hmm?
Yes, sir.
Correct,
Yes, sir. Yeah.
I think you followed hawks. Have you heard of this word? There will be an hawks.
Yes, sir. I heard, but I don't know much about that. But I heard that word, sir.
Bandwidth hawks.
Yes, sir. I heard.
Because when we talk about bandwidth hawks, right,
Yeah. Yes, sir.
this word basically, right, we use as and when you started working with internet services. Okay,
Yeah. Okay, sir.
because when you started using internet, you may be required, right, more bandwidth than the normal users.
Okay. Okay.
I think you can understand why such variation is basically, right.
Yes, sir.
Okay, the reason is that the moment you started accessing the internet, your traffic is more and more basically, correct?
Yes, sir.
Because let us say I want to access some web portal, what will happen? Suddenly some advertisement will come, right? Is it not?
Yeah.
Suddenly some right, screens are going to be displayed. I need to close it, right? Then I need to push on uh, to my task basically. Okay,
Yes, sir.
in the sense that uh, the internet user requires more bandwidth than the regular users. Okay.
Hello. Yes.
Yeah, can you able to hear me? So we
Yes,
we,
I
we
can.
say, right, internet use, yeah, internet users bandwidth is a bandwidth hog basically, right?
Oh,
Not the
yeah.
normal users, not the normal users. I think you understood why that
Yes.
variation happens and all. I'm
Yeah.
trying to explain it with some examples, that's it.
Okay, sir.
Right, no? I
Yeah.
mean,
Yes, sir.
these are all you need to be explore it, right? Because as and when you
Yeah.
start writing your answers,
Yes, sir. Yes,
once
sir.
you get that word, you should in a position
Yeah.
to talk about what is it, okay, how things are going to happen. It that is what is the effects of congestion is. Effects of that word is basically. Yeah.
Yes, sir. Yeah.
And lastly, I think you can understand poor network design and subnets. You know.
Yes, sir.
In a simple manner, probably. I think you might have noticed this as and when you visit some offices or colleges or maybe right now corridor somewhere else here and there when you visit, especially where they have not given a focus on proper designing of network, correct?
Yes, sir. Yes, sir.
Even let us say sometimes you might have seen your cables are laying down just like that. Okay, that's all poor design,
Yeah.
because there may be a data loss because of a poor network design.
Yes, sir.
This unnoticeable sometimes. It is like transmission loss we say with respect to electricity, correct?
Yes, sir.
What happens if they are not right, properly lay down their transmission wires? There may be power loss at the junction point all the time. Nobody notices it, correct?
Yeah. Yes, sir.
Same thing happens here also. Here we talk about there is a data loss. There we talk about there is power loss. That's it,
Yes.
right? And also we talk about there have been subnets, poor network design, and there have been subnets. I think you have studied right, subnets also. See,
Yes.
it may not be possible to have more and more number of networks for an organization, basically. Correct?
Yes, sir. Yes, sir.
In the sense that let us assume that, right, for an organization like RBC or maybe any organization in that matter,
Yeah.
you are trying to have there will be one network IP basically, okay,
Yes, sir.
where your data is going to flow through, right, that IP to different subnetworks which are designed in a campus or designed in a corporate office, in a designed in a multi-story building, designed in a research organization, like that. However, right, if they are not properly configured and designed,
Yes, sir.
then your data coming in from a different sources to your networks, okay, and it never flow through different subnetworks in a proper order basically, right?
Yes, sir.
Then it leads to a congestion basically. we say no sometimes we have not received the data, right? No, why it happens? Because if the poor design or proper flow, I mean, structured very well, basically. Hmm?
Yes, sir.
It's a common problem, however we do it. And also, if there will be a lot of data is going to be flood, and if they are not maintained, also it leads to there will be congestion, basically. Hmm?
Yes, sir.
It is something like that. You are traveling on some road, correct? No, there may be an accident on the road, correct?
Yes, sir.
That they need to clear it so soon, correct? If not, what will
Yeah.
happen? Congestion is going to occur.
Yeah. Yes, sir.
That's what is going to happen it with respect to, right, network design and subnets. Hmm?
Oh, yeah.
You can write a very good answer relating to effects of congestion, right?
Yes, sir. Yeah.
Yeah, you can go through it and you can explain me, right? What is your understanding by looking into this graph now? Take your time, one minute time. You can take it, understand, analyze, and then you can start.
Sir, good put is like throughput or what? Some other meaning? I didn't. The first time I'm hearing good put, sir.
That's good.
Yeah.
Right,
Yeah.
yeah, packets flow across a network, right?
Yes, sir.
Right. Hello. ನಮಸ್ಕಾರ. Class, class ಅಲ್ಲಿ ಇದೀನಿ. Okay, okay, okay. I'll call up after 11. Okay. Sure. Yeah. Will it start?
Hello. Yes, sir.
Yeah.
So, some when network started from the one channel, so overloaded is like uh, capacity of that network, capacity of that channel. So good put is like so how efficiently data has been transmitted. So when it started flowing, so capacity of the network is some like every network having some capacity of ideal will be there. So when started, uh, I didn't get much, so so
Okay,
yeah,
no problem, no problem. No, just to understand your right, quick response to the given question. How you're going to react? How is your you know right quotient analytical skill? I wanted to measure it basically.
like just looking at, I can understand that some network is there, but while come to the explanation part, I can understand. So if it is overflow, if it is happen like this, so congestion occurs. But when come to the networking part, I have to use some technical words for this. So
But I am observing slowly you're improving it. Correct,
yes,
Yeah.
yes, sir.
So I'm just noticing that right very closely.
Yeah.
See, let us assume that square, whatever it is there, square shape looks like. Okay,
Yeah. Yeah.
let us assume that is a complete, environment or a platform which is available for you to send your data from one network source to the another network source. Right.
Yes, sir. Yeah.
Okay. Now, initially, when I started utilizing the available network resource, correct?
Yes. Yes, sir.
Let us say I start, doing something from my end. I will start slowly, correct?
Yes, sir.
What happens when I start slowly? You're going to digest that.
Yes, sir.
What will happen to the throughput of that? That will also be very good.
Yes, sir.
Correct, let us say I
Yeah.
send one data packet, second data packet, third data packet. What will happen to that throughput? That will be very nice.
Yes, sir.
So your graph, your curve goes right in a linear order fashion, slowly, in an incremental order, correct?
Yes, sir.
There won't be any problem because you have not reached the maximum right resources or the capacity of your network resource. You can able to do your job. It's a very ideal situation, a very a comfortable zone you are in. Correct.
Yes, sir.
Okay, what happens if I reach to the maximum capacity? Let us say the yes, you reach to the maximum. There is a saturation region. Even that is also no problem. Correct.
Yes, sir.
That's the ideal situation basically. What if I am trying to send further? Will it be possible?
No, sir.
Network resources are not available.
I will.
Dropping of data packets are going to happen. Okay,
Yeah.
right. Congestion is going to occur. It
Yes, sir. Definitely.
correct.
Yeah.
As a result, you can't do it anything basically. It is something like that. Let us assume a scenario wherein you are going in a two wheeler or a four wheeler, right?
Yeah.
Car. You go with a speed of 20 kilometers. Slowly you increase to 30, 40, 50, 60, 70, 80, 90, 100, 120. No, still that may be an ideal, correct?
Yes, sir.
What if you're trying to cross that limit also? It's
Like,
going to collapse, right?
it will not be in our control. Yes, sir.
It's not under your control. The resources is
Yeah.
not available finally. It is going to
Yeah. Yeah.
collapse. Accident
Yes,
is going
sir.
to occur. It's
Yeah.
congestion basically.
Yeah.
Correct,
Yes, sir.
Even if you take your computer also, let us say, as you know that, right, we use the concept of multitasking. It's
Yes,
about
sir.
programming, right?
Yeah.
Let's say
Yes, sir.
CPU can handle 5 jobs, 10 jobs,
Yeah.
15
Yeah.
jobs. See, it will handle multi-programming in the sense that if you pushing so many things to it, what will happen? It going to thrash at one time point of time. Correct?
Yes, sir.
It's a congestion, basically.
Yeah.
It's also happen with human being also basically. Correct?
Yes,
Let's say
sir.
you have one job, you'll do it comfortably. 2 jobs, you do it. 3 jobs, you may do it. 4 jobs, you may do it. If I keep on pushing, more and more number of jobs to you, okay,
Yeah.
without bothering about, the throughput level of yours, right? You're not going to do it anything at one point. Totally, it's a congestion,
Yeah.
correct?
Yes, sir.
So a good put is basically an application level throughput per unit time. What is right? You are trying to do it. That is what is a good put is. Good put is nothing but a throughput. We call that is an application level throughput,
Okay. Yes, sir.
right?
Yeah.
That's what is the understanding is. You need to explain the effects of congestion, whatever you understood in the previous slide with respect to this particular diagram. Hmm?
Okay, sir.
When you are in the comfortable zone, when you are in the best situation, worst situation, or ideal situation, or when it is going to be collapse, like that, you need to write. Yeah, no.
Yes, sir, clear.
Now you can read this and you can talk about this now.
Hello.
Yeah, yeah, I'm listening.
Yes, sir.
Yeah.
Yeah, like so when large network, so large scaling is there. So example, so when we are passing in one, when we have some long queues, generally for you are giving something, you are taking our assignments. So there will be some long, if it is every all 18 are standing there, so it will be take time to finish your work because you have to take everyone's, and there will be like it's a small, it's a large queue. Um, so when come to the internet like so latency, I think like when packets are transmitting in a so in a queue manner, so delay, definitely delay will be occurs. So when the delay will be occurs like so mm, so arrival rate near the link capacity. Oh, mm, so there might be have some chances of packets drop at the mm,
Yeah.
yes, 1 second. Okay. So, sir, some link is there, networking link is there. It has some certain capacity is there. So, when the packets are transmitting in the large queue, like if it is some small pipe is there, it has some capacity. If it is a long queue is there, so passing of that all the packets in that, it will be takes a time. Definitely, it will be a delay is there. So, in the network, internet congestion also same thing is happens, like some has some capacity of that link is there. So if it is has a long queue, a large number of queue means at that time, so we can't transmit the packets very fastly. So at that time also definitely it will be occurs in the delay form. So unneeded retransmission of by the sender sometimes, like so senders will be, when senders will be send retransmission will be occurs at the sender. So at the destination, so acknowledgement will be sometimes receiver will be sent a duplicate of acknowledgement. So when data send packet is not arrived, so it has to send the retransmission of the package.
So sometimes like so a receiver may send a duplicate of acknowledgement. Sometimes will be original. So there will be unneeded of retransmission by the sender sometimes. So when packet is dropped along the path, the transmission capacity of upstream router has been wasted. Mhm.
Yeah, fine.
Yes, sir. Yeah.
Yeah, yeah. I mean, you are trying to talk about what is the effects of congestion with respect to internet, correct?
Yes, yes, sir.
Earlier we were not talking about, right, internet traffic basically. Now we are trying to talk about internet traffic. Okay.
Yeah.
What happens in case of internet traffic? Obviously, there will be an large queuing delays are going to be occurred, okay, are going to be constructed basically, okay. The reason is that
Yes.
we don't know one or the other way without knowing to our notice the data may be traveling through our network, correct.
Yes, sir.
See what we are supposed to do it for that, that is going to be handled by, there will be the router at a particular network, that, correct, where
Yes, sir.
routing tables sends, there will be the updates to the neighboring routers, so that that router knows that how the data needs to be forwarded from one network to the another network, like that, right.
Yes, sir.
That is one aspect, correct. The another aspect is, okay, the router says that the data need to be flow through, you know, this particular network only. However, when the data is entering into that network, the link capacity of that network may not be as good as we expected. Correct,
Yes, sir.
Because of that, what will happen? There may be a delay in it, right?
Yes, sir.
Because of there will be a delay, every packets are coming into the same path. Obviously, a congestion is going to occur.
Yeah, yes, sir. Definitely.
Once if the congestion occur, obviously the next immediate router is going to face heavy congestion, and lot of time is going to be wasted like that. It is something like that. Everybody is passing through a tall traffic in Bangalore or maybe wherever it is so. Unless if they are not having a fast now, if everybody there in the queue, what will happen?
Yeah, so definitely congestion will be occurs if
Congestion
everyone
is
is
going
in.
to occur. Very simple,
Yeah, 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 sir.
Because they need to go through that. Obviously, everybody will go very fast, and everybody will stop there in the so near toll, right?
Yes, sir.
Because everybody need to pass through that basically, right?
Yes, sir.
So obviously, congestion occurs at that particular location or a router, whatever it's so.
Oh,
That is what happens most of the time in case of internet congestion. Why I'm saying this is, not only that, let us assume that take an example of, right, the entire data, whatever we do at a different geographical location in India,
yeah.
okay, you are sitting at some place, I am sitting at some place, somebody is sitting at some place, they are pushing some data, but when the data going through, right, from India to the other network, it has to go through via VSNL only, correct,
Yes, sir.
Videsh Sanchar Nigam Limited.
Yes,
It's a gateway for Indian network, right?
yes, sir.
Irrespective of the network, there is a a congestion obviously which is going to occur at that particular router. right?
Yeah.
We need to think about how we need to handle that kind of a situation, basically, right?
Yes. Yeah.
We
Yeah.
need to think about how we can efficiently forward your data packets from this network to the another network without wasting much time. If so, there will be a congestion. Hmm?
Yes.
Yes. Yeah, just see this now. You try to understand, right? And explain me what is your understanding from this diagram now.
Yes, sir. Like, so it's a large queue, like router from the network VPN. So one internet user is there. So another from a VPN two user. So second internet user is there, sir. Like when if the every internet user has single routers, so easily we can pass. So that both internet user have using only one router. So there will be there is definitely occurs the congestion is occurred there, sir. So
Okay.
yeah.
Then
So yeah, in the second VPN, like already congestion is there. So again passing through the other router. So there also congestion will be congestion occurred. So
okay.
yeah.
What is the role of VPN here?
VPN. So virtual private network VPN role.
What is the role of VPN? Why do we use there is an VPN?
I read, sir, but I forget it. I'll go through that, sir.
Hmm?
I read about this, sir, but I don't remember it properly. Role of that
What is VPN?
virtual private network, sir.
Okay.
Yeah.
Yeah. See, this right virtual private network VPN gives you, correct?
Yes, sir.
It's an online privacy and anonymity by creating a private network from a public internet connections, basically.
Yes, sir. Yes.
Correct,
Yes, sir.
because of that, what will happen? You can, avoid some kind of congestion which occurs at router one,
Yes, sir.
as and when it pass through to the next router.
Okay. Yeah.
You understand?
Yes, sir.
Right. Because if everything is going to become, there will be the public data, right now.
Yeah. Yes,
You are
sir.
trying to, provide some kind of, privacy for your private data, obviously.
Yes,
Correct.
sir. Yeah.
There won't be much congestion as you expected. Basically.
Yes, sir.
That's what happens, most of the time. They've used now FASTag, right? Because of the FASTag, right? People are, going through, right, very fast, right?
Yes, sir.
If they don't have FASTag, then there will be the congestion. They will come to in a queue, and obviously there is a congestion there. But somehow it has been right taken care to address that issue, basically.
Yes, sir.
Correct,
Yes, sir.
I mean, this is a one simple scenario of your internet traffic with respect to maybe internet user one and user two, right? Assume a scenario wherein you have there will be an n number of millions users. They are trying to use internet services. What happens to your routers?
So definitely congestion will be more. So in such cases, that how will they improvise this avoid this congestion control? So when internet users are more,
Then
if it is
yeah, see what they do. They use a congestion control, right? No algorithms, right, at every stage, basically, right? You have studied so many algorithms to handle that kind of a situation.
Okay.
Correct,
Yes, sir.
and based on that software instructions, right, your data traffic or a network traffic is going to handle it basically. That's it. That's why
Okay.
sometimes, as and when you are accessing your network services, it will happen so fast. Sometimes
Yes,
it's
sir.
very slow. Correct,
Yeah, yes, sir.
sometimes it may be a moderate, but in all the situations for the same kind of service, your latency is not going to become same.
Yeah.
You understand?
Yes, sir.
It is like that only. See, let us assume a scenario wherein you're traveling from Bangalore to Mysore, the bandwidth remains same, correct?
Yes, sir.
And you may be traveling with the same car with the same driver, and the bandwidth is same, distance is same, but your latency is remains same.
Mm.
Your time is remain same all the time.
No, sir.
No, it varied, correct,
Varies. Yeah, yeah, it varies, sir.
it varied based on your road traffic, right?
Yeah.
Sometimes
Yes,
it
sir.
may be 3 hours, sometimes it may be 2.5 hours, sometimes it may be 5 hours, correct, no? It varies.
Yeah, yeah, yeah.
So, if you want to avoid that congestion, what you do, you may select some other kind of path for it. That's where
Yeah.
you have a nice road to reach that, right?
Yeah.
You pay the toll and you go with VPN.
Yes, sir.
You
Okay.
understood, your
Yeah, yeah.
experience remains same all the time, probably.
Yes, sir.
Correct,
Yeah.
That's how the role of VPN comes here.
Yes, sir. Got it, sir.
Hmm?
Yeah.
Well, you see, once you have something with you that you have to understand and relate and talk about it, okay. Conceptually, you have to understood well and implement it and know the pros and cons of it and describe about each and every point very clearly, what is required, what is not required. That's it.
Yes, sir.
Clear, no?
Yes, sir.
But one thing you need to remember at this point is that, right, however you do your good design, right, or maybe, providing very good, infrastructure or, good, what you call, there will be an services also, there may be possibility of failure. You cannot say it's an abnormal situation, correct, no? Some eventuality occurs, something happens, there may be congestion, correct,
Yes, sir.
that happens in case of your network traffic also. We can't do it, but we need to right, handle that kind of a situation quickly. That's it, right?
Yes, sir.
That's what happens most of the time. When PU results comes or SLC results comes, everybody would like to access the server,
Yeah, yes.
right? So
Yes,
server
sir.
crash, right? Incident happens. Obviously, server may not be available for the whole day, correct?
Yes,
Because of
sir.
the congestion issue.
Yeah,
Hmm?
yeah.
It cannot handle that load which is coming in from a different input sources, right? To provide the service, right, to the queries of the input, requirement. There's a delay. There's a queuing delay happens, right?
Yes, sir. Like, sir, in such cases, that what they will improve in the server, sir, to
What they
make it.
improve it in the server? Yeah. See, they're not going to improve it anything but lower basically.
Yeah.
They are trying to set some kind of time slots, right,
Okay.
to handle that situation. That's it.
Okay.
Privileges they may set it, right, no?
Yeah.
Let us say
Okay.
during the first 10 use, I mean 1 hour, okay,
Yeah.
it can handle there will be 1 lakh students' request like that.
Okay.
The
Yes.
moment if it exceeds that limit, obviously it won't accept it.
Okay. Yes, sir.
They may be there in the queue. Once that is served, then the rest of the students may join into that queue. Right.
Yes, sir.
Then there won't be any congestion. You may ask me a question: why they have not done, well in advance of this? They can do it well in advance. Correct, You may ask me
Yes.
that question, but
Yeah.
they won't do it. The reason is that, right, they assume that everybody won't enter, right, with a particular intent done with.
Yes, sir.
See, there are thousand, vehicles are available. Right. Do you expect that all thousand cars are going to be in the same time?
1 second, sir. There's a lot of disturbances.
Yeah, yeah.
Yeah. Okay.
Correct,
Yes, sir.
This is this where it leads to the ribbon congestion basically.
Yes.
If you take one apartment wherein you have that when say for example 5,000 cars, okay.
Yes, sir.
If all 5,000 cars suddenly right entering into the road, what will happen? Congestion occurs.
Understand.
What happens to the security at the security itself? Congestion, no.
Yes, sir.
If happens, what the security people need to do at that apartment? They never thought of
Yes.
it initially,
Yes.
correct. But to handle that situation, they have observed that from the past 1 month, this is what is happening here. So then what they will do, they will come out with some kind of a policy to address that with some time slot. Right?
Yes, sir. Yeah.
As a result of that, there won't be any congestion basically.
Okay. Like,
Correct?
so when come to this apartment example,
Yeah.
like they may open another gate,
Hmm.
so or else make some time slot. So morning to 10 o'clock, these many cars has to go like this. So in the server settings, there is only one way to make the time slot, or like some other like they may expand their server. Is there anything like this?
No, they don't have any other plans only because the reason
Okay.
is that where they have only one exit. It's like
Okay.
gateway, correct?
Yes, sir.
The server accessibility is a gateway.
Yeah.
It's an one entry point, one exit point. That's all.
Yes, sir.
You cannot give there will be multiple entry points and multiple, exit point. If
Okay.
you do it like that, then what will happen? Then again, providing a security to your server, your infrastructure itself is a very tough task.
Yes, sir. Definitely.
You understand?
Yes, sir.
You cannot have that basically
Okay.
because if you have there is a multiple entries, right? Then having that and consolidating and if there is any slight mismatch happens at different locations, then there is a huge right security breaches basically.
Yes, sir.
Correct.
Yes.
Even that happens with respect to your computers also, right? Accessibility should be at one point. You cannot have that in multiple points. Okay.
Yes.
Yes, it is possible
Yes.
to do it, but however, issues are going to arise more and more.
Yes, sir.
That's why they won't right design like that basically.
Yes.
Clear?
Yes, sir. Yes, sir.
Yeah. Yeah, you can go through this now.
Sir, one more question, not related to this, sir.
Yeah, yeah.
So yeah, in one of my interview, they asked me like, can you explain me UDP in practical manner, like how in generally examples like TCP I can give like whatever I browse in, I can call this is TCP. Like How will you explain practically UDP, sir? Like,
UDP in practicals, huh?
yes, sir. Like
Uh,
how real time it will be works, how exactly it works.
hmm.
Yeah.
What you can do it is right. You know that some of the basics on there be in UDP, correct?
Yes, sir.
It's a user datagram protocol,
Protocol.
right? It's an half duplex, okay?
Yeah.
Stream oriented,
Yes,
correct?
sir.
Right? You know, protocol. The moment we use there is an UDP, right? Protocol,
Yes,
okay?
sir. Yeah.
Uh, you can talk about any kind of media streaming applications is the best example for your UDP. Okay.
Yes, sir. As I said, like media streaming, like
Yeah.
that come up with like next question. How in media streaming, how it works like this?
Yeah. What you can do it is
Yeah.
you have to create a structure in it basically. Correct.
Yeah.
In the structure in the sense that let us say I create one right a packet where which includes these data types. Okay.
Okay. Yeah.
Say for example, what is the size of the data packet? That's one thing. Okay.
Oh, yeah.
Second one maybe what is the right file you use it, for example,
Yeah.
or what is the message you use it in it. Okay.
Yeah.
All those things you need to be embedded in a structure.
Okay.
Correct.
Yes, sir.
Even in case of TCP also you does the same thing, right? In case of any TCP or UDP, right, client server interaction happens, you need to think about that basically. Okay, how do you create a TCP UDP a structure, right? Then
Yes.
after creating that structure you need to think about how do you establish a socket connection between your client and a server.
Yes, sir.
Correct.
Yes, sir.
And the moment you want to create, I mean, if you have created, there's an socket connection between these two, right? Client and a server. You need to remember the other primitives which, right, required for the communication purpose further. Okay,
Yes, sir.
which includes maybe, right. We talk about one is going to become what do you call right now you have to bind your address, correct? Because unless you are not binding the address of your devices and a network, it may not be possible basically. Okay,
Yes, sir.
you need to use there is a bind. Then you need to make use what you want to read, which port you want to read, all the things you have to write it, that in the sense that you have to utilize the appropriate primitives used in case of your client server interaction with respect to TCP application with respect to UDP application. That's all.
Yes, sir.
And you should have the right concept of socket connection. Without
Okay.
without creating a socket, it is not possible to do any kind of there will be communication basically. That is the core basically.
Yes, sir.
If you does
Uh,
that, then automatically things are going to happen.
okay. Sir, one more question, sir.
Yeah.
So, ARP protocol we use
ARP.
yes, ARP, so address
Okay.
resolution protocol.
Yeah.
So they told me to give like generally. I said like some definitional answer. So give me general example like this. So I said like so an RTO office is there. Um, so I have vehicle. My plate I have to RTO office is ARP protocol. It's a resolution. So my vehicle number plate is like plate is IP. So like I said like every device has a one. Every vehicles will be having a some numbers which has been printed on the vehicles itself. It's from the companies. Companies will be provided if some hundred black color Royal Enfield vehicles are there. So every vehicle will be having its own unique number. This has been printed by the companies on the bike only, sir. This is like MAC address.
Mm.
RTO office is like ARP protocol. So yeah, the RTO office will be giving the vehicle number on the plates, like some series is like this. This is IP address. So it is ARP protocol exactly works like a RTO office. This is what I understand the general concept, sir. Like they asked me like explain me in more understandable manner. So how could I make them to understand that practically?
See, now what you should tell for them is, look, you have an right IP packet, correct?
Yes,
Packet.
sir. Yeah.
What it consists of?
IP packets addresses, sir. IP addresses.
Yeah, you have a source address, you have a destination address, correct?
Yes, yes,
And
sir.
you have, there will be the data in it as well, right?
Yeah, yeah,
So as and when it comes from, there will be the source network, that is from one IP, okay,
yeah,
which is going to be delivered to a right destination, okay.
yeah,
It going to check that whether it is mapping to that address. See, it is not that destination IP is not mapping. It forwards to the next one, next one, right?
yes, sir. Yeah,
Yes, it maps to my network. Once it maps to my network, now, correct,
yes, sir.
there is a MAC address in it, correct?
Yes, sir. MAC address.
Again, it checks that whether it maps to that, MAC address or not.
Yeah,
If it maps, that is going to be delivered to that. That's it.
yes, sir.
If not, it is going to, right, forwards to the next. I mean, it never forwards basically. It sends to the right, you know, what is that host itself. It is something like that. Let us say you are ordering something
Yes.
via Amazon, right? For Deepavali shopping, ma. Okay.
Okay.
You are given your address to them. You are given all the details, right?
Okay. Yes, sir.
You are the host basically. You are there in some network, right?
Okay, sir.
They will receive your order. Okay.
Okay. Yeah.
So it may be there in the shipping for 2-3 days, right?
Yes, sir.
It will come to Bangalore.
Okay.
They will come and they will deliver to you only, no?
Yes, sir.
How they will do it?
Mm.
It's an ARP only, correct?
Yeah.
It's a ARP protocol. Simple,
Yes, sir. Yeah.
right?
Yes, sir.
The moment if they want to schedule, I mean deliver your data to you, they ensure that this is the Bangalore packet, big box, correct? It may come in a
Yeah.
cargo,
Yes, sir.
correct. Once it come to Bangalore cargo, they will receive it up,
Yeah.
wherein you have, there will be a number of bundles in it. Once again, IP bundles.
Oh. Okay.
Again, they will segregate that bundles.
Yes, sir.
It will go to the particular region.
Yeah.
Again, they will open it.
Yes, sir.
They will check it like a subnets again.
Yeah. Yes, sir.
Then it will come to you. That's it, with the
Yes.
address, destination address.
Okay. Then here like that Amazon, that guy will be works like a ARP, sir.
Exactly, correct.
Yes. Okay.
Is it not?
Yes, sir. It's right, sir.
You can relate so many. See the whole right scenario. I
Yes.
mean, without, because of your applications only, the network has been developed such a big way basically.
Yes, sir.
You understand? Let us say whatever we do in a day to day,
Yeah.
we are trying to implement the same thing with respect to real time hardware infrastructure to do your digital data communication basically.
Okay.
And we does that, that's it. And it ensures that our operations are going to become much more simpler now. Otherwise, what you
Yeah.
are supposed to do, one person go physically to Delhi and he has to do all the things physically, correct,
Yes, sir.
and does the job and come back. All these things have been prevented because of this,
Yeah.
right, digitalization and computer networking, right, and data handling, a lot of many things. Look at hardware, look at software involved, right? Look at the technology involved. Look at the how you can going to solve many challenges which are coming in, right?
Yes, sir.
Look at about accounting, look at about transactions, look at about there'll be an QoS. All these things are small jobs where a software engineer sit and writes at one point, yes, this is what is. After doing some kind of validation, right? They will try to deploy that code into a particular server, right? And they will ensure that a quality of service is achieved to achieve that particular task, basically.
Yes, sir.
Clear, no?
Ah, yes, sir. It's clear.
Yeah. Do you have any questions?
Uh, no, sir. Like, in the interview, sometimes like brain will be
No,
blocked, sir.
I
When it comes
understand.
in.
That's what. See, what happens when we ask some questions immediately, you may not
Yeah.
have an answer because sometimes mind may be a blank.
Yes, sir.
Correct, or
Yeah.
sometimes what will happen in an interview, you cannot answer, just like that.
Yes, sir.
Like now I am giving a time, you are thinking and you're saying, suddenly if I ask you in the examination, no, examination, I cannot ask you like this.
Yeah.
You have to be answer it quickly.
Yes. Yes, sir.
Correct, you have to come out with your answers. We need to
Yes.
extract it and we need to evaluate how fast you're going to react.
Yes, sir.
Correct,
Yes, sir.
so they will ask you so many things. You can answer it right, thinking in a proper way, that's it. Hmm?
Yes, sir. Sir, like one more problem is with this telephonic is, sir, like they will be asking questions. So it's happened with one of my friends, sir, actually.
Okay.
Yeah, she was giving answers like she's taking time. Obviously, if they ask in the suddenly, then we can't tell like this. So what they think like you are googling and you are telling answers like this. But when come to the if they ask you like this real time example, we can't Google it and tell them. When if it is face to face, that would have been best
No,
than
see,
this. Yeah.
it's you can switch on the video during that particular
Ah,
time
yes, sir.
and you can answer
Yeah.
it. Okay, that's
Yes,
one
sir.
thing. So when the interview is going on, you try to avoid such things, googling it.
Yes, sir. Yeah.
Be honest and trying to present it. It will be always good.
Yeah, yes, sir. Even they can smarter than us. Like if I do some such things, they can easily identify all the things, sir.
Yeah. Let us say if we started asking, some more questions, basic
Yeah,
questions, then
yeah,
we can understand that whether capable or not, something like that. That's not a
yeah,
hmm?
yes, yeah,
Clear, no?
yes, sir. It's clear.
Yeah. So, I mean, a lot of things are there to relearn. It's not an end of it, right? You have to study more and more, right? Now the whole, right? The exercise is that. That's it. Okay.
Yes, sir.
Because however you study, however you know some of the things, you may not be possible to hold on for a long time. Correct? No, you
Yeah,
can wipe out.
yeah,
So you need to refresh it. Hmm?
yes, sir.
I think expecting. from everyone same kind of work.
Yeah.
Okay, we'll meet you tomorrow again at 11:30. Okay, and just
Okay.
I want to engage, right?
Okay.
Completely if it is one also because my contents are ready, right?
Yes, sir.
I need to go through it.
Okay, sir.
Yeah, fine, ma. Okay,
Yeah.
bye.
Bye.